Hello everyone. This is a wonderful question from the topic of converting galvanometer to ammeter. And this will be the last question before I enter a new topic, okay? And this one is very technical. So there is a need for you to pay attention on this, okay? Now the question says, when a galvanometer shunt with a resistance 0.05 ohms gives a full-scale deflection for current 2 ampere. Then a resistance of 495 ohms is placed in series with the galvanometer. It gives a full-scale deflection for 10 volts. Calculate the resistance of the galvanometer and the current required to produce a full-scale deflection when no resistance is connected. Now, this question is talking about this galvanometer. You understand? He said that when you connect shunt, when you connect shunt resistor to galvanometer in parallel, you have converted this galvanometer to ammeter, and that will give it power to measure a current of 2 ampere, because this question, it has shown that it has been converted to ammeter. That's why it can able to read 2 ampere. So they connect shunt resistance in parallel. That is why this galvanometer can read 2 ampere. Therefore, we have converted it to ammeter. Then the same galvanometer is also converted to voltmeter by connecting another resistance called multiplier. Please check previous question. Called the multiplier. We connect it in series. It is a very big resistance, 495 ohms. Then shunt used to be small. The multiplier used to be big. Whenever you want to convert galvanometer to ammeter, you put a small resistance which is shunt in parallel. Then whenever you want to convert galvanometer to voltmeter, you put a very high resistance called the multiplier in series with the galvanometer. You now convert it to voltmeter. So the same galvanometer is giving a very high resistance in series. That is why it can measure 10 volts, 10 volts, 10 volts power, 10 volts voltage, okay? Now the question now asks us to find the resistance of the galvanometer itself, the original galvanometer. What is the resistance of the original galvanometer? Please check the previous question. You understand what I mean. I've treated in online. Then in the same question say we should also calculate the current required to produce a full-scale deflection. It says that we should also calculate the current that the galvanometer itself can measure when no resistance is connected. So the current, we will now calculate the current that the galvanometer can measure on itself and the resistance of the galvanometer on itself. Now, let us calculate it. Now, calculating, we have introduced formula for calculate the resistance of this shunt when you want to convert galvanometer to ammeter, and I have also introduced you on formula to calculate multiplier resistance whenever you want to convert galvanometer to voltmeter. Now we'll now write the formula now. Now the formula says Rs equals to Ig Rg all over I minus Ig. Now this is the shunt we are talking about, okay? This is the formula if you want to calculate it, but it's already given here, right? So this is the shunt, this is the current of the galvanometer, and this is the resistance of the galvanometer we are looking for. This one is the main current it has measured. It's given here 2 ampere. Now for the multiplier, when you want to convert it to voltage, it is V minus I G R G all over I G. This is the multiplier resistance is already given here, and this is the voltage it can measure, it's already given here, and the current of the galvanometer we are looking for, and the resistance of galvanometer we are looking for, and still current of the galvanometer. Now we will equate this formula. Okay, we will now find, okay, let us use this formula now let us use this formula to find the resistance of the galvanometer. Now, making Ig subject of formula here, we now have multiply this, cross multiply, we now have Ig. When we do cross multiply, make this one over 1, cross multiply the up one times 1 here, and this one times this, making the subject of formula we want to do equals to Rs in bracket I minus Ig. Okay, making this a subject of formula, we divide both sides by Ig. We now have Rg equals to Rs in bracket I minus Ig all over Ig. Okay, making the subject of formula. Now let us make the same Rg subject formula using this formula. We now do cross multiply, make this one all over, cross multiply. Okay, we now have V minus Ig Rg, this one times here, okay, to give us the same thing. This time this will give us Rmig. Then take this one to the other. Okay, let's take this one to the other side so that it will be easy for us. Bringing this one this side will now be V minus Rmig equals to Ig Rg. Make this one subject of formula, divide both sides by this. We now have Ig equals to V minus Rmig all over Ig. So since we have find this one to be this and the same thing to be this, we now equate them. Let us, this is equal to this, Rg equals to this, the same Rg equals to this. Since this is equal to this and this one is equal to this, we now have the right to equate this and this. It will now be Rs in bracket I minus Ig all over Ig equals to this one, V minus Rmig all over Ig. Okay, we want to find the current. Okay, now going further, we now have here Rs in bracket I minus Ig equals to, bringing this one up here in bracket, V minus Rmig all over Ig, so that Ig here cancel Ig here. Okay, we now have Rs equals to Rs in bracket I minus Ig equals to V minus Rmig. Now, please let us, the formula where we make use of is this one and this one. Let us clean all that. Hope you follow. Okay, now let us open this bracket. We now have Rs times R to now be Rs minus Rig, okay, equals to V Rmig. Okay, correct like terms. This and this have the same thing. Okay, we now bring it here, right? So now bringing this one here, we now have Rmig, because when we bring it here to be plus minus Rsig G, okay, equals to this one V. When we bring this one this side, we change to minus RSI. Okay, now we'll factorize G. Now have G in bracket Rm minus Rs equals to V minus Rsi. Making this a subject of formula, now have Ig equals to V minus Rsi all over Rm minus Rs. We now want to make this a subject formula. That is why we are doing all these things. Okay. Now let's clean this side to have space. I succeeded in making Ig subject formula, and that is the one they say we should calculate. Okay. We are now calculating for the current first, current of the galvanometer, which is Ig equals to V. V is given to the 10, and the 10 minus Rs is given, that is shunt resistance, given to the 0.05 times the main current, which is 2, all over Rm, which is 495 minus Rs, which is 0.05. When we continue, we now multiply. If we multiply now, we now have 10 minus 0.05 times 2 is, it will give us 0.1 all over this minus this 494.9595, which is, when we subtract, we now have 9.9 all over 494.95. The answer is 0.02 ampere. So we have succeeded in calculating the current they have given us, that they say we should calculate here. The current is 0.02 ampere. That will be current that will give full deflection to galvanometer when there is no resistance attached to it, apart from the resistance of the galvanometer, which we will calculate now. Okay. Now let us calculate for the second question, which says we should calculate the resistance of the galvanometer. So we can use any formulas. Either we use this one or we use this to calculate this resistance. So let's use the first one, which will now give us Rs is given to be 0.05 in bracket 2, which is the main current, minus the current of resistance, which we have calculated, 0.02 ampere, all over the current of the galvanometer, which is 0.02 ampere. Okay, so when we subtract from here and multiplied with this, we will now have 0.099, okay, all over 0.02. When we subtract 0.02 from 2, the remaining one, we multiply it with this, it will give us 0.099 all over 0.02. And when we divide, what will it give us? It will give us 4.95 ohms. 4.95 ohms. So the resistance of the galvanometer is 4.95 ohms. So please, if you like this, please share it, comment on that, and subscribe and follow. Thank you so much for watching. May God bless you.